Welcome guys to the chapter 11.2 and 11.3 homework. So we're going to go over both sections. Now you're going to notice, looking at question number 1, it's going to say it's removed. There's going to be a lot of those from this point forward. The reason for that is because of the time constraints that we have. So this is the first time we see it, but expect a lot of these. Okay guys, so let's move on to the next one. All right, here we go. We have a question. There are 6 performers and who will present their comedy, and it says here, how many different ways can we schedule the performances? Okay, so we got to think of the 6 performers like almost like a race. So how many people can go first? Well, there are 6 people, so there are 6 choices for first person. Once that person is picked, how many people can be second? Well, now there's 5 people left, so we can choose between 5 people, and then and on it goes, right, until it reaches to the last person. Has no choice. He's just going to be last. This is another way of saying 6 factorial. Remember that, guys? So we're going to get our calculator and figure this out. What's that number going to be? 6 times 5 times 4. 720 different ways that these people can be lined up. So let's see if we're right. 720. All right, good job. All right, next question. I'm going to clear this up. Okay, question 3 has been removed. Okay. Question 4. Okay, here we go. Got a question. So let's continue. A club with 7 members is to choose the 3 officers: president, vice president, secretary. If each office is to be held by one person, no person can hold more than one office. How many ways can those offices be filled? Okay, so we're going to assume that they're all qualified. So we have 3 positions, but we have 7 people to fill it. Think of a race. There's 7 people racing, and then only the top 3 winners, right? Well, how many people can be first place? Well, technically, there's 7 people. 7 people can be first place. So there, once we figure out who's first place, now, or who's president, right? Whatever. Now we can figure out who's vice president and how many people are left for vice president. There's 6 people, and now that that's taken care of, we'll put secretary. How many people can be secretary? Well, there's only 5 people left. So we just multiply it out, and these are all the possible ways. Another way I'm sure some of you guys might want to do it would be like this on your calculator. The order does matter, so we want to make sure it's a permutation. So let's go ahead and the order would matter because who's president and who's vice president are different, right? So if, let's say, person A is president, person B is vice president, but then you switched it, now B is president and A is vice president, that's a completely different scenario, right? So that's why permutations are meaningful here. But I'm just going to go ahead and do 7 times 6 times 5. I got 210. So that's how many ways. So let's type it up. 210. Fantastic. Alrighty. Let me clear this up for a second. I see that this question has been removed. So we're going to move on. 6 has been removed. 7 has been removed. Oh, wow. Okay, 8. Oh, this is a drop-down question. Okay, so let's read it, and then we'll see what the answer is. So, determine the following problems. Involves permutation or combinations. It's not necessary to solve the problem. Okay, a medical researcher needs 47 people to test the effectiveness of an experimental drug. If 159 people have volunteered for the test, then how many ways can 47 people be selected? So there, does the order matter if you're the first person to take the drug or the last person to take the drug? Does the order really make a difference for this case? And I would say the answer is no, it wouldn't make a difference because it's not like a race, right? So I would call that a combination because the order does not matter. Okay, that's nice. Alrighty. Let's see the next question. Similar. Okay, so it's asking us how many different 5-letter passwords can be formed from the letters O, P, Q, R, S, T, U if no repetitions are allowed. Okay, let's see. When you do the password, the order does matter. If my password is OPQ and your password is POQ, they're different passwords, right? So the order matters. We call that a permutation. The order does matter. Oh, that's easy. These questions are really easy. Okay. 10 has been removed. 11. Perfect. So of 13 possible books, you plan to take 4 with you on vacation. How many different collections can you take? Okay. So there, it doesn't matter the order, does it? If I were to have 13 books, excuse me, and I took, let's say, the first 4 books right in front of me, but it didn't matter in what order I picked them up. I'm still taking those 4 books. We call that a combination. So a nice way of doing it would be like this. It would be 13. Oh, let me put the writing thing. It'd be 13 combination 4 because I'm taking 4. 13 meaning the number of books, and 4 is the number of books I'm taking, the size of the group. So that would be 13 factorial over 13 minus 4 factorial, then times 4 factorial, right? That's the formula. So we're going to have 13 minus 4 is 9. So it's going to be 13 times 12 times 11 times 10 times 9 forever, right? But 9 down to 1 over 9 factorial, because 13 minus 4 is 9, times 4 factorial. The 9 factorials are going to cancel. That's convenient. So we have 13 times 12 times 11 times 10 divided by 4 times 3 times 2. You don't have to care about the 1. So let's see. 12 divided by 4, that's 3. And check it out. 3 canceled out with this 3. And 10 divided by 2 is 5. So we're really just multiplying 13 times 11 times 5. Let me get my calculator. 13 times 11 times 5. I got 715. So let's put that answer. Let me turn off the chat thing, the writing thing. 715. Alrighty. Next question. Let me clear this up first. Okay. The next question has been removed. So I'm not kidding, guys. I took a lot of questions out, obviously. All right, we have another one here. 13. So from a club of 23 people, how many ways can we form a group of 5 members to be selected to attend a conference? Okay, so again here, I wouldn't consider this to be a situation where the order mattered. If I got selected to be in the committee, whether I was the first person to get picked or the last person to get picked, it doesn't matter. I'm still in the committee. It's not like I'm getting a position or something for being selected first. So we're going to say this is 23 combination 5. So it's going to be 23 factorial divided by, 23 minus 5 factorial times 5 factorial. I'm just going to go ahead and put this in my calculator. I actually have this in my calculator. So I'm going to put 23 combination 5. And if you guys bought the calculator I asked you to buy, then you should see this as well. That should be in your calculator. So just remember, the order didn't matter, so I used combination. Earlier, I forgot the one. It was about the position of president, vice president, whatever. Permutation question, because the order did matter. So instead of a C, I would have put instead of this C, I would have put a P there, because for that particular case, the order matters. But here it didn't. So the answer I did in my calculator, was 33649. So, alrighty, excellent. Let me clear this up. And we have another question right away. Okay, so how many different 2-letter passwords can be formed with the letters A, B, C, D, E, F, G if no repetitions are allowed? So I'm just going to go ahead and do this the easy way, instead of thinking about permutations, which is what it is, right? I'll do it both ways. I'll tell you what. So I have 2 different letters, and I have, let me see, 1, 2, 3, 4, 5, 6, 7 letters to choose from for the first letter of the password. And then the second one, once I choose that letter, since it can't be repeated, no repeats, I have only 6 left. Okay, so that's all you got to do, and you get your answer 42. Or you could have done it this way. There's 7 letters, and there's a permutation with groups of 2. So you're gonna get the same answer. Okay, so whichever way you decide to take it, just make sure when you do it that you understand whether order matters or not. Okay, so there you go. It's 42. Excellent. We have another question. Let me clear this up. Okay, next question. You have 16 ice cream flavors. Okay. How many cones with 3 different flavors can you create if it's important to you which flavor goes on the top, middle, or bottom? Okay. So here, since it's important, obviously it should be important, right? You don't, if you like would love vanilla, and that's the first thing you want to taste, you want that to be in the top one, right? So, this is going to be a permutation, 16 different flavors, but you want a permutation of 3, only 3 of those 16, and that's it. Okay, the formula would be 16 factorial divided by 16 minus 3 factorial, right? That'd be the formula. Okay, or you would have this situation, it'd be 16 times 15 times 14. That's all you would have to do, one of those two. So 15 times 14, I got 3360, so let me just type that in there. 3360. Excellent. All right, let me clear this up for a minute. All right, this question said it's been removed, and the last question's been removed. Excellent. So we're done with all the homework. So that's it for chapter 11.2, 11.3. Hopefully you guys find this easy, so get ready for 11.4. All right, take care.